Hello again. In this video I'm going to talk more about the image system and especially the cameras in this robot. As you can see, there are three basically web USB cameras bought from a company that makes these cameras for security systems. Why three? Okay, if you have just two cameras and based on how you orientate them, they can see either very well in front of the robot, very close to it, or very far. And that's important for having the images, separate images from different angles, for making stereo disparity maps and kind of point clouds about where objects are located, shapes and so on. And no, in general, a lot of the stereo processing. But humans have these two eyes are actually, with humans, as we look closer, if you notice, they're just turning inwards. If you're looking right close, something, let's just say right next to your nose. But the robot is unable to do that, so I added a third camera there, and hopefully it will be able to compensate this issue. There are several problems with the current using USB web cameras. One is that when you take these images from each camera, you cannot be sure, when it's going to the Raspberry Pi, in this case they're connected here, you cannot be sure if the image taken from this and this come exactly at the same time. If you just connect them like this, they most likely, almost for sure, will not be taken at the same time. So if there's motion, that can have problems with creating the stereo image. However, there is possibility sometimes with some cameras that you can do an internal connection between them that forces them to synchronize. And this is what I'm at least planning to do with these cameras at some point, to force them to be synchronized with each other. However, will that realize the way I'm intending it to happen in the Raspberry Pi when it's receiving the images? I'm not sure yet. I will tell you more about it later once I get to that point. Other issues with USB is that despite the fast transfer speeds towards the Raspberry Pi, the actual latency, meaning from the time that takes from taking the image to time that is received in Raspberry Pi, that is quite long, as there's even some default latencies defined in the USB standard, which we cannot affect in any way, despite the high speed. On the other hand, again, human eyes have a quite a large latency as well from the moment it's received in our retina to the moment it goes back to our visual cortex. So I believe with some neural network related solutions it would be possible to compensate for that lag. Okay, then someone might ask why I'm not using a commercially available camera. Since everyone is doing 3D vision and vision stuff now, it's like everything is ready. Well, most of when you read about from university level publications or crowdfunding, this documentation from companies trying to do vision stuff, most of these are overly optimistic and they kind of don't want to tell the truth about what is the current level of technology and knowledge and so on when it comes to computer vision and especially robotic vision. For example, many of the cameras which you can buy online, which are meant for kind of 3D stereo cameras, which some companies make, there are quite few of them. Most of them are actually similar to the Kinetic, and basically most of them are based on the fact that they project, let's just say somewhere from near the cameras, an infrared pattern onto a surface, which dimensions they know exactly. So with the cameras they triangulate the estimated distances on objects and so on. However, if you go outside where it's sun, a lot of infrared radiation, it will not work there. In most environments, this application on long distances, and in some cases, depending on how the focus of the lenses is done, also at very short distances, it becomes totally unusable. Then there are some devices that don't use it and claim to have its processed solely based on the images, have maybe even special circuitry, special semiconductors made for this purpose. But the issue is still that very often they have very low resolution and the refresh rate of the image or the depth map is not fast enough, not even close to what would be required with a robot that's actually supposed to interact with humans and move in a real environment instead in a laboratory. And the third one, the problems they often have is that they have a very small resolution. And despite even the small resolution, in a few cases where I try to figure out is the processing actually done here, very often they sell this very expensive camera, they process the image, each one camera, they just only thing that happens inside the camera box itself is that they combine the images together and stream it out through one USB, and they maybe do the synchronization, but that's about it. Very often still then when you read the papers, they make an SDK and you have to buy a huge computer to connect to this device just to process and get the images, and that's quite expensive and not very usable if you want to have a truly mobile robot. I will tell more in another video about the processing which I'm planning to do, and the computer, the Raspberry Pis and the neural networks and so on stuff which I'm going to try to do with this robot. See you in the next video.